You can say the design and development of our engines, of course, follow the need from the market. And the driver for us as an OEM have for many years been the emission control legislation, but of course also the fuel prices is quite an important factor. We have, for that reason, optimized the design. We have increased the pressure. We have increased the pressure not only for high load, but also for low load, covering, like you say, the slow steaming. We have seen a general trend that also for CO2 saving, that the vessels are sailing slower today than they used to do. So we optimize for the whole entire load program, increasing the maximum combustion pressure. We do that for several reasons, but also because we need to still apply for the Tier 2 NOx. So we cannot just, look specifically on the fuel oil consumption. It has to be balanced with the technical code. When we do that, this higher pressure, together with the sulfur content, the water in the inlet air, and the temperature of the liners have all an impact on what we see the cold corrosion. Cold corrosion have always been there. There's always been the risk. And of course, these different factors will result in a certain level of cold corrosion, like the pressures, temperatures, water content, so on. This has been a challenge. We do admit that. We have worked and are working very close with oil companies, major oil companies. We have our research team doing a lot on the mechanical side, and we have found a solution now, and this is introduced to the market. The tool how to secure that your cylinder condition is perfect and you use exactly the feed rate of cylinder lube oil that you need. This is what we call the sweep test or drain oil analysis. This is the drain or the oil from the scavenging drain below each cylinder. And by measuring the iron content and the base number, you will know how is the wear regime for that single cylinder, and do I actually utilize the right amount of lube oil. For the oil side, there is the increase from BN70 to BN100. We will have more neutralization in that way, stopping this cold corrosion. This, of course, also goes with the amount, but by using this higher BN, you will be able to have this low feed rate. In principle, if you continue with a BN70, you will have a very high feed rate, which will not be economical either for the operator, and it will not be good for the engine condition itself and the build-up of deposits and so on. On the mechanical side, then we are looking at the liner temperatures. The temperatures is, of course, extremely important. When will what will be the dew point in this combination of thermodynamic and chemistry, and the higher temperature we have on the liner walls, the less risk we have cold corrosion, and better we can control the cold corrosion, which is obviously there always in some way and some form. So we have gone in and we have created, you can say, a cooling of the liner, but ending up with a higher temperature in the regions of the liner walls where we see the need. So we have been more specific on the cooling of the liners today. This is how this is solved. For the industry, there will be the BN100 to be used for all engines later, for Mark 8 and later versions. For the engines before Mark 8, there are still some engines which is optimized and could have cold corrosion. But this is individual. Far most of those engines are operating without any complications in that direction. We have tests showing clearly that if you use a BN100 for these engines which have cold corrosion, you can go very close to where the minimum feed rate, 0.6 gram per kilowatt hour. You cannot do that with 70. You even can end up on a very high level, which is therefore not recommended. So continue with the BN70 is not a good idea for those engines. So as a sum up, and from our side, we will see that we see the cold corrosion issue actually solved. What is important is to follow our recommendations, and this is what we have specified and shown in our latest service bulletin